Yes, the bitch is back. 2 days in a row. Yeah, so today just gonna do a little vlogging. I have been working on my OpenGL game engine framework, whatever it's gonna be. I don't really know. So I think I will show a little bit of that. I'm also going to the museum later with my friend and just working on actual work stuff at my 9 to 5. Yeah, I don't know. Also, did my hair. Look at that. My friend Sage says black people call this draping when your hair is hanging down. I got the metal things on there to make it do that. I wish it would do that normally because this feels fun, but it mostly won't do that because my hair won't grow long. Anyway, let's I'll show you my OpenGL framework. Okay, I'm terrified that I'm gonna record all this and it's just gonna be unusable because I'm back on Linux. Oh no, this is not a good thing. Also, I'm about to go to the gym. That's why I have a C4. You know what it is? I'm extremely predictable. All right, so here is my game engine framework, whatever. I called it OpenGL because I'm a Midwest princess. So basically what we got in here is, let me clear the screen. And so in the LS, we have a few different folders. So we have a build folder, we have an include, which has all the header files. So if we look in include, we just have a few headers. We have glad, we have KHR, which is included with glad. That is for providing like cross-platform stuff for OpenGL. Also, we have a shader class header. We have a texture class. Well, they're structs. They're not classes, but anyway, we have a class for, or a struct for loading textures, a struct for including shaders, and then we have STB image, which is a header only framework that that helps you load images. So, and then if we check out the resources, that's where I'm keeping my shaders. So we have a fragment shader, vertex shader, and then also two images from the Learn OpenGL tutorial, which I'm working my way through. And then in the source, we just have the glad implementation file. I hope you can't hear my laptop fan. You might be able to, it's fine, whatever. And then I have the shader implementation file, and then my main.cpp, and then we have our third party, where I just have glfw, that is for window opening and handling keyboard input and mouse input, and glm, which is a math library. I'm not using glm just yet. I will as I continue on through this. Oops. So source. Let's take a look at the main. This is very closely following learnopengl.com. So if you really want to learn this stuff and not just like vibe with me, I would recommend actually reading it. It's a free book. It's very good. It's a little bit older, but everything you learn in there is still applicable on most platforms. Mac OS, obviously, if you saw my previous video. Mac, Apple deprecated OpenGL on their platforms. They want you to use Metal, which I also have a video about that. But if you're on Linux or Windows, you can still use OpenGL. It's they kind of want you to move towards more modern frameworks, but you don't have to. I'm learning Vulkan. On Windows, you can either use Vulkan or DirectX 12, I believe, or Direct3D 12. On Linux, you're kind of stuck with either OpenGL or Vulkan. Vulkan is basically the more modern version of OpenGL, but OpenGL still works, so there's nothing wrong with learning it. It's a little bit easier to get started than Vulkan. I think I mentioned in my video yesterday how annoying it is to just get a triangle rendering on Vulkan. So I'm trying to really learn Metal and OpenGL and eventually tackle Vulkan. I've been reading up on it a little bit, but Metal and OpenGL just are easier, so I've been doing those. I'm a noob when it comes to graphics programming, so I want to learn the basics first before I start taking on really difficult tasks. I love caffeine. Okay, so what we have here in our main file, and I want to break this up probably because it is getting a little long. So if you take a look here, all we're doing is including GLAD and GLFW. These are just headers to make cross-platform stuff easier, and also like window opening, different stuff that is very platform specific, easy, and cross-platform. And then after that, I'm just including my shader file, my texture file, and then IOStream just for printing to the console. Here we have a callback function, and that just changes the size of the viewport whenever it's called. And then we have our process input function. So all it's doing right now is checking if the escape key is pressed, and if it is, it's setting the window to close. Here we have some vertices and indices along with colors and text coordinates. This is data that we're sending to the shader to actually do the drawing. And here, and let me know in the comments if you want me to do like this is how you draw a triangle in OpenGL type video, although I don't think you do because no one watched the how to draw a triangle in Metal video. But I mean, OpenGL is obviously much more popular, so maybe more people be interested in it. But also, there's a million tutorials. Just read the book. Just read it. Not that hard. I'm sorry, that's rude. If you want me to do it, please let me know, because I would love to. But if not, just read the book. It'll teach it better than I can, because I'm very not an expert in this stuff. But yeah, here we're just initializing GLFW, and then we're telling it different things. These window hints basically just tell it different things to do when it opens the window. So we tell it what major version of OpenGL to use. We're using version 4, minor version 6, and then we're telling it to use the core profile. There's two different profiles of OpenGL. There's the compatibility profile, which is older and I guess easier to use, but the more modern one is the one you should be using. So we're using the core profile. Here we just create a window, give it a name, height and width. These should probably be in constants because we're probably going to access them more than once. So at some point I will do that. Yeah, here we just check if the window is equal to null, and then we make it the context current. Here we initialize GLAD, and here's where we tell it what our frame buffer size callback is. And then here, this big chunk of code, which probably can be put in its own struct or class, is where we actually send the vertices to the shader so that the shader can actually use them. So VBO, VAO, and EBO are abbreviations for different buffers, and that we can send to the shader. So we create a buffer, and that buffer will be this. The VBO buffer is a vertices buffer, and that will be this info. It has the positions here. It got a little messed up when I copy and pasted it, so it looks weird. But the positions is the first 3, and then the next 3 are colors, and then the last 2 are texture coordinates. And then the EBO is where we send the indices to it. So basically, because these are the coordinates for a square. Normally a square would have to be 2 triangles, and it would repeat the different vertices for a square. So we have these indices to say we actually want to repeat these. So we're using indices 0, 1, and 3, and then 1, 2, and 3. Basically to tell it to reuse those vertices so we don't have to repeat code. I get to explain that more in depth, but also this is just a yap sesh. So if you have questions, you can leave it in the comments, or you can read the darn book. Anyway, take another sip. That was more than a doggone sip. That's damn near a gulp. Anyway, then we have my struct for creating textures. We just send in the actual textures, and then we have our struct for shaders. We give it the path to the shaders, similar to the textures, and then we tell it to use the shader. We set each texture. We send it as what's called a uniform, which is a uniform is just data you can send to the shaders. They can be updated easily. So we only have to send it one time. So we do it outside of the run loop. So this would be basically your game loop. So we just say while the window should close, we process the input, we set a background color, and then we bind the 2 textures, and then we again use the shader, and then we draw those triangles with the indices. And then we swap buffers, which if you watch my metal, I don't know if I explained this actually. I maybe explained it. Oh, actually, no, I think I explained this in the video where I lost all the footage because my computer froze. In graphics programming, in order to not have like black screens in between frames, it will render one frame in the back and then put another one in front. And then once the back one is rendered, they swap the buffers. So it just keeps swapping back and forth. Back one is rendering, front one's being shown, and then they swap. Now front one is being rendered, back one is being shown, but obviously the back one is now the front. Whatever. So that's just how like screens are rendered. That happens every frame, and then we just poll for events, which is we check for any events that happen in the process input. After that, we delete our vertex arrays. I actually think I forgot to delete the EBO, so I gotta do that too. So we're gonna say delete EBO. Okay. And then after that, we just terminate GLFW. So if actually, I'm just gonna run it to show you. So I'm building this with CMake. As you see, I have a CMake list .text file. CMake is just a build system for building C and C++ projects. So if I build it, it gives me a warning, but I'm ignoring that. It's just from GLM because it's using an old version of CMake. And then after, that'll generate a make file. If you were on, say, Apple, it would generate an Xcode project. If you're on Windows, it would generate a Visual Studio project. So yeah, on Linux, it makes a make file. You could also do a make file on other platforms, but why would you? Yeah, so we make it, and then it will just create our executable. So notice we have those two textures. We have the container texture, which is just the wood thing in the back, and then we put the face on top of it. And they mix the. I'll show you in the shaders. You mix the two textures. That's why the smiley is kind of has a lower opacity. I just looked at my I just got a comment on a video from an old coworker. He said, spend less time doing iOS and spend more time doing Android. No, Pete. Yeah, I saw it. And you done got caught while I'm recording. I will not. I'm gonna do neither. I'm doing C++, you jerk. Yeah. Yeah. I said it. Anyway, love you, Pete. Thank you for commenting. Okay, back to this. Let's see. I got so thrown off by that happened in real time. That was amazing. Oh man. Anyway, let's see. Oh yeah, I want to show the shader. So if we take a look in our resources, so events and resources, yes. I gotta do resources shader dot show the vertex shader first. So this is a vertex shader. Shaders in OpenGL use a language called GLSL. It's very similar to C, but it has like extra stuff like that are like important to graphics. So vectors, matrices, that kind of stuff. So these, this like layout location equals 0 equals 1 stuff, that is telling the vertex shader what position each of those buffers start at. So the stuff we passed in, those arrays, that will be here. So we pass in the position at index 0, color at index 1, and text coordinates at index 2. And then all we're doing in here is we're casting the position to a vec4 and just like throwing in a fourth coordinate and then setting it on the special special variable called GL position that just tells like what position you want this vertice to be at. And then we're just doing, so you can take in things and pass out things. So we take in these three things and then we pass out the color and text coordinates. So all we're doing is setting those equal and then passing them out, and those will get passed to the fragment shader. So if we quit and go to the fragment shader, notice we have our matching in with our color and text coordinates. Color is not even being used though. And then for a fragment shader, you always have the frag color as the out. And then we have those two uniforms that I mentioned that are being passed in. They're both what are called sampler 2Ds. So it's just a picture one is a JPEG, one's a PNG. STB image handles that. And then here we set the frag color to a mixture of the color from the two textures. And this 0.2 is the percentage of the second one. So that's why the smiley face is lower opacity. And that is the shader. And I will show you the shader class. So that is in source. Shader.c++. So here, all we're doing is we have a constructor that is defined in the header file. And it just takes in two paths, two strings, and those are paths. And then we open up files with them, read the buffer into a buffer, get the string from that, close the files, convert them to C strings, and then from there, we use the contents of those files. In OpenGL, you actually have to compile your shaders on the fly. So that's why I had to grab the contents of the file and put them in a string. And then we compile each shader, check if it was successful. If it wasn't, we just print an error. And then we create a program. That is our shader program. We attach both shaders, we link them, and then we check if they link correctly. And if they did, we just delete them. Otherwise, we just say file's not read. And then in this program, in the function for use, we say GL use program ID. And then these are just three helper methods for setting those uniforms. So we go back. The only thing else that I wanted to show is the texture class. So that is fairly simple. We just include STB image, and then we pass in a texture number. OpenGL requires each texture to be numbered, but you can just add them because they're contiguous in memory. So you just add the texture number that I passed in to it. And then from here, we have to say whether it's a PNG or not. And we have a default of false. If it is a PNG, it has to use RGBA because PNGs have transparency, JPEGs don't. So, but other than that, the only thing interesting here is we generate the texture, we give it an ID, we bind the texture, we set how it wraps. So we just wanted to repeat if it has to wrap, and then this is just to handle if something's far away from the camera or close to the camera. We want to use a lower resolution image. So we do that by generating what's called a bitmap. It just creates different resolution versions of the image, so it doesn't waste memory using a big image if something's tiny. So that's what that does. Here we have to flip it vertically because by default, for some reason, when they're loaded, they're upside down. And then we just load the image. We set that stuff, whether it's a PNG and then a bunch of other stuff. If it doesn't work, we send an error, and then we have a function called bind, which just binds the texture to the text coordinates. And that's really it, all I have now. That's all that is required to show that square. So it's a little bit farther than a triangle, but it is not very much farther. Next, I plan on working on coordinate systems, matrices for like rotating camera. So I can create like a kind of a first person camera so you can go walk around and stuff. But yeah, I'm going to just finish my C4 and then hit the gym, and I'll probably check in this vlog a little bit later today. I don't know why I always make that face after I I'm like, thanks for watching. I don't know why I do that. It doesn't make any sense. It's weird. Anyway, see you soon.
Words will always fall short.